Task 3.2. Understand the fundamental concepts of security models. And before we begin, remember, if I don't go deep enough in any topic, that's what the prompt at the end of the session's for. All right, we're going to go over a few security models that might show up on your exam. These include 1. The Bell-LaPadula and STAR models. 2. The BIBA model. 3. Graham-Denning. 4. Clark-Wilson. And 5. Brewer and Nash model. Remember, these refer to operating systems. It's important to understand how these security models aren't isolated concepts. They're interconnected and parts of a holistic security system. So some systems might implement pieces of both the Clark-Wilson and, say, Brewer and Nash. So as we go into each model, let's discuss their primary focus, the key principles, and real-world applications. Let's get started. The Bell-LaPadula and STAR models. These are focused on confidentiality and widely used in military and government sectors. It's also supported in Red Hat Linux and any other SC Linux, though it's not the default. It's made up of 2 key properties. The simple security property, referred to as no read up, which ensures that users at a lower security clearance cannot read higher security information. And 2, the STAR property, or no write down, sometimes called no spillage. It ensures that somebody at a high clearance can't purposefully or accidentally leak information on, say, lower security devices. Now, the strong STAR is a kind of a combination of the BIBA and the Bell-LaPadula, so this prevents users from reading or writing up or down, and sometimes called the containment property. For the exam, it's crucial to understand how these models protect data confidentiality in high security environments. The BIBA model, sometimes called the upside down Bell-LaPadula, its focus is on integrity. So the 2 properties are no write up, which prevents a lower trusted integrity user from writing something at a higher integrity rating, and no read down, preventing somebody at a higher integrity rating from reading a lower integrity data item. BIBA classifies both data and subjects based on integrity and maintains consistency, and it's crucial for maintaining the accuracy and trustworthiness of data. For the exam, it's important to understand how BIBA compares to Bell-LaPadula. They are both multi-level policies. Bell-LaPadula is for confidentiality, and BIBA is for integrity. Next, the Graham-Denning model. The Graham-Denning model is a framework that's associated with managing permissions and access rights. And some key points are: it provides an access control framework, a structured set of rules for managing user permissions and access rights. 2, 8 commands or attributes you see in files. So this defines more than just the read-write. We have create and other properties, and it allows for more granular approach or control over user actions. In NTFS partitions, they implement this. You'll see where you have additional properties in NTFS. For dynamic management, one of its strengths is supporting dynamic changes to permissions, allowing for flexible access control management as needs change. And 5, security policy enforcement. It helps enforce security policies by clearly defining and managing access rights and operations. For the exam, it's crucial to understand how the Graham-Denning model differs from the multi-level policy models we just mentioned, BIBA and Bell-LaPadula. In real-world applications, you see it all the time. The Clark-Wilson model. Also a data integrity model, but not multi-level like BIBA. It ensures data integrity through 2 main mechanisms: well-formed transactions and separation of duties. A well-formed transaction means that we maintain a log to ensure data integrity. All data and any changes to data must be made through a predefined transaction that maintains the consistency of that data. Separation of duties. In this context, it ensures that a user or a subject cannot access an object, data, without going through a program to prevent direct access to that data, say through a shell command. 4. Targeted mode. In SE Linux, that's a light version of the Clark-Wilson model, which is the default of Red Hat Linux, the only operating system right now that was rated by the US government in the common criteria. And 5 real-world applications, we see it all the time. It's used in commercial environments to ensure that data is modified only in legitimate ways. For the exam, it's important to understand how Clark-Wilson models differ from the BIBA model. Remember, it's not a multi-level model. The key is well-formed transactions and separation of duties. Brewer and Nash, sometimes called the Chinese wall model. When you take your exam, you'll be sitting on a Windows machine that implements this. You'll be allowed to load the test engine or a web browser, but you can't do both. That would be a conflict of interests, and that's the main point. To prevent conflicts of interest, we implement the Brewer and Nash model. It provides a dynamic access control. It'll adjust the security based on user actions. Once you load the browser, can't load the engine. And its use cases commonly applied in financial and consulting firms to avoid conflicts of interest. The rules of operation, the model operates on the principles that a subject can only access one data set from some conflict of interest class. Once they've accessed that data set, they're prevented from accessing others in that same class. For the exam, it's crucial to understand how the Brewer and Nash model differs from the other security models, where Bell LaPadula and BIBA have that multi-level or hierarchical process. All right, so summarizing and wrapping up here. 1, confidentiality models, and really that's just Bell LaPadula, the strong star implementation of that. 2, integrity models. We have BIBA, that's multi-level, and we have our Clark-Wilson model. And other access control models with other focuses. So again, the Graham-Denning model focuses on attributes or data access rights and ownership, and the Brewer and Nash or the Chinese wall model is a dynamic access control to mitigate conflicts of interest problems. So test your knowledge. Come on, get into it. I hope you guys are getting into it now. We're already on 3-2, and I hope you're tweaking step 5, right? You want to deep dive into any subject Larry didn't get. And you may have noticed at this point, sometimes the LLMs go a little off track. Just give them a quick reminder. All right, see you soon.